Yeah. So today we are going to discuss the problems related to the second case of particular integral. So that is trigonometric case. Okay. So solve the following problems. Yes. Solve d square plus 4 of y is equal to sine 3x plus cos 2x, where d is equal to d by dx. Okay, so find out as usual the complementary function and particular integral. So for finding complementary function we need auxiliary equation. What is that? It is given by m square plus 4 equal to 0. Okay, so we get m equal to plus or minus 2i. The roots are imaginary. What is the complementary function? That is y is equal to c1 cos 2x plus c2 into sin 2x. Okay, so let us write this as 1. Now we need to find out pi, particular integral, that is given by 1 by f of d, that is d square plus 4, and the given function we need to write. What is that? Sin 3x plus cos 2x. I am breaking that into two parts. So we get once again 1 by d square plus 4 of cos 2x. Okay, so now according to the second case of pi, we need to replace d square by minus a square. What is a here? It is 3. Okay, and here the value of a is 2. Okay, so when I replace, so we get to 1 by minus 9, that is minus 3 square plus 4 and sine 3x. Okay, plus, and here when I replace d square by minus a square, where a is 2, we are going to get minus 4 plus 4, that is giving us 0 in the denominator. That is the case of failure, right? So what we need to do here, we need to multiply by x in the numerator and differentiate the denominator with respect to d, that is derivative of d square is 2d. So plus 4 derivative is 0 and cos 2x. So now by continuing this, we are going to get sin 3x upon minus 5 plus x by 2 into 1 by d of cos 2x. 1 by d means integral of cos 2x. What is the integral of cos 2x? That is sin 2x upon 2. Okay, so now by simplification we are going to get minus sin 3x upon 5 plus x by 4 into sin 2x. This is the value of pi we get. So finally, as usual, we need to add a complementary function and particular integral to get complete solution. Okay, so write complete solution is equal to complementary function plus particular integral. Okay, so let us try to take down one more problem. We'll write find the particular integral of d cube plus 1 of y is equal to sine of 2x plus 1. Okay, so now here we need to find out only pi. So for that we write 1 by f of d, that is 1 by d cube plus 1 of sine of 2x plus 1. Okay, and this d cube can be taken as d into d square, and for that d square we need to replace by minus a square, that is minus 4 plus 1. Okay, we write as it is sine of 2x plus 1. Okay, so now by simplification we write it as 1 by 1 minus 4d. Okay, now here we don't have d square to replace with. Okay, so for that reason we need to multiply and divide it by the conjugate of 1 minus 4d, that is 1 plus 4d. You multiply in the numerator and divide by the same term in the denominator. Okay, so now we continue with this. So by continuing with this, we write in the numerator, we can operate with the term sine of 2x plus 1. So that is 1 into sine of 2x plus 1 is sine of 2x plus 1 plus 4 into d of sine of 2x plus 1. What is meant by d of that? So d of that means derivative. Okay, so let us write down one more step. D of sine of 2x plus 1. Okay, and in the numerator what we need to do, we need to multiply. This is just like a minus b into a plus b, that is giving us 1 minus 4d square, right? So 4d whole square, that becomes 16d square, and thereby we have to replace d square by minus a square, right? So that is 1 written as it is minus 4, that is 4 into 4 16, d square means minus 4. Okay, so now by simplification we get sine of 2x plus 1 plus 4 into d of that. What is the derivative of sine of this one? That is cos of 2x plus 1 into 2. Okay, so into 2, and in the denominator we write 1 minus into minus plus 16 4s are 64. Okay, so finally we can conclude the answer. So that is sine of 2x plus 1 plus 2 4s are 8 into cos of 2x plus 1 all divided by 65. So this is the answer for that. Okay, so now we can have one more problem, right? Third one, solve d square minus 4d plus 1 of y is equal to cos x into cos 2x plus sin square x. Okay, suppose if you have this kind of material in RHS, while finding particular integral, we can't directly replace d square by minus a square. We need to use formula first. Okay, so what is the formula? Cos a cos b formula, and for simplifying sin square x we need to use 1 minus cos 2x by 2 formula. Okay, so let us find out first of all the complementary function. So for that we need to write auxiliary equation. What is that auxiliary equation? It is m square minus 4m plus 1 equal to 0. Okay, so now by using the formula for m, we get m equal to 2 plus or minus root 3. Okay, here the roots are irrational. So what is the complementary function? It is given by y is equal to e power 2x into c1 into cos hyperbolic root 3x plus c2 into sin hyperbolic root 3x. So this is the value of CF. Okay, let us call this 1. Now we need to find out PI. So for finding PI, as usual, we write 1 by f of d, where f of d is d square minus 4d plus 1 of the given material. What is that? Cos x into cos 2x. Okay, so plus, by breaking the material, we write 1 by d square minus 4d plus 1 of sine square x. Now we can use the formula. Okay, what is the formula for cos A cos B? We need to write. Okay, so by applying the formula, we get 1 by 2. I am writing outside. 1 by 2 into 1 by this d square minus 4d plus 1 of cos of A plus B, that is cos 3x. Okay, at the same time I am breaking the term, so plus 1 upon d square minus 4d plus 1 of cos of A minus B, that is cos x. Okay, we get cos x, so close the bracket there, plus 1 upon d square minus 4d plus 1 of sine square x. What is the formula for sine square x? That is 1 minus cos 2x upon 2. Okay, now we need to find out the complement, the particular integral for each case here. Okay, so let us continue parallelly. We get 1 by 2 into, here we have to replace d square by minus a square, right? What is the value of a here? A is 3. Okay, a is 3 here, and here the value of a is 1. Okay, so by replacing d square by minus a square, we are going to get minus 9 here, right? So that can be taken as 1 upon minus 9. Okay, minus 9 minus 4d written as it is plus 1. Okay, cos 3x write as it is plus so take down the second term, and here we need to replace d square by minus a square, where a is 1, that is given by 1 upon minus 1. Okay, minus 4d plus 1 of cos x. So this is what we get for the second term, and here you take 1 by 2 outside and apply d square minus 4d plus 1 for the term 1, and 1 can be taken as 1 into e to the power of 0x. Okay, where a is 0. So that means replace d by a, because this is related to the first case. Okay, so by replacing d by a, where a is 0, we get 1 only for the first, minus, okay, minus, this is second case. Okay, so there we replace d square by minus a square, where a is 2, we get 1 by minus 4 minus 4d plus 1 of cos 2x. This is what we get. Okay, so now continue with this. We write 1 by 2 into simplify this. So by simplification, we are going to get minus 4d minus 8. Okay, minus 4d minus 8 of cos 3x. Okay, and then here minus 1 plus 1 you can cancel, and the remaining thing is minus 1 by 4d of cos x. Okay, and here also 1 by 2 is there, so we can take completely common, and we write here plus 1. Okay, minus, and here this becomes minus 4d minus 3. So from there you take minus outside, that becomes plus 1 upon, so 4d. Okay, so plus 3 you will get into cos 2x. Okay, so can we continue that? So this is giving us 1 by 2 into, okay, and here we take minus 1 by 4 outside. if I take minus 1 by 4 outside, I am going to get here d plus 2. Okay, and here I need to multiply and divide it by the conjugate of this d plus 2, that is d minus 2 in the numerator, d minus 2 in the denominator, right? Into cos 3x minus 1 by 4 into, here we have 1 by d into cos x, that is integral of cos x. What is that integral of cos x? That is sin x. Okay, so plus 1 right as it is, plus, and here also we need to multiply and divide it by the conjugate of the denominator, that is 4d minus 3 divided by 4d plus 3 into 4d minus 3, okay, of cos 2x. So now by simplification we get 1 by 2 into minus 1 by 4 of, what is the d of cos 3x? That is derivative. Derivative of cos 3x is minus 3 into sin 3x, okay, minus 2 into cos 3x, okay, divided by d plus 2 into d minus 2, that is giving us d square minus 4. Okay, so we need to replace d square by minus a square. What is a? 3. So minus 9, okay, d square, so minus 4 right as it is. Okay, so then here we take 1 by 4 into sin x, or we write plus 1 as it is, plus 4 into d of cos 2x. What is the derivative of cos 3x? Cos 2x, that is minus 2 into sin 2x, minus 2 into sin 2x, okay, minus 3 into cos 2x right as it is, divided by 4d plus 3 into 4d minus 3, that becomes 16d square minus 9. So that is 16 into d square. What is d square here? Minus 4. Okay, right here minus 4. Then minus 9. Okay. So now by simplification we get 1 by 2 into minus 1 by 4, and here you can take minus outside from these two in the numerator, and here also you can take minus outside. Okay, so minus into minus plus, we get 3 into sin 3x minus 2 into cos 3x divided by 9 4, that is 13. Okay, so minus sin x by 4 plus 1. Okay, and here also we can take minus outside both in numerator and denominator, that becomes plus only. So 2 4s are 8 sin 2x plus 3 into cos 2x divided by 73. Okay, so this is our final answer for PI. So finally what we need to do, as usual, to get the complete solution, add a complementary function with the PI. Okay.